вести не только занятия, работать, но еще и провести конференцию международную, что тоже, в принципе, благодаря технологиям. Итак, на сегодняшний день у нас в этом году почти 200 докладов на конференции, более 300 участников. Конференция представлена 12 секциями и более 30 организаций. Из университетов, которые представлены, значит, это еще университеты 3 стран. Это из российских университетов, это Кубанский государственный, Новосибирский государственный технический, Оренбургский государственный университет, МИЭД, мои федеральные университеты. Так что вот мы постоянно расширяемся. Более того, в этом году, помимо публикации в журнале «Известия ЮФУ. Технические науки», мы предоставили возможность опубликоваться в 2 других журналах. Это «Известия высших учебных заведений приборостроения», издательство университета ИТМО, и «Известия высших учебных заведений России. Радиоэлектроника», издательство ЛЭТИ. Это ведущие журналы, и на следующий год они у нас также сохранятся. Они все входят в ВАК, публикация абсолютно бесплатная. И мы надеемся, что на следующий год даже будет иметь возможность публиковаться в этих журналах, соответственно, и попасть в базу цитирования Scopus. Переходим к следующему докладу. Я хотел бы отдельно сказать, и скажу еще большое спасибо профессору Ратнадипу Тишмуху за то, что он к нам присоединился. Следующий доклад у нас будет Саяпов Азамат, заместитель директора компании ООО «Аркада», инновационные технологии компании «Альтаир», инжиниринг, уникальная система лицензирования.
Да, добрый день, коллеги. Я хотел бы удостовериться, хорошо ли меня слышно.
Прекрасно слышно. Мы готовы вашу презентацию включать.
Да, хорошо, я сейчас подключаю. Так, видно ли сейчас мою презентацию?
Сейчас подгружается еще. Секундочку.
Ну, пока еще нет, да, надо подождать.
Она загружается, ничего страшного. Сейчас включим.
Угу.
У нас на сегодняшней конференции в этом году более 30 организаций приняло участие. И самое важное, мы хотим совмещать науку, образование и промышленность. Надеюсь, у нас это получится. И получается.
Так, ну как, подгрузилось там?
Нет, пока еще не подгрузилось. Ждем.
Подгрузилось?
Азамат, как слышите, нету пока ничего.
Алло, да.
Да, Азамат.
Теперь видно мой экран?
Нет, видно ваш аватарчик.
Странно, я нажал поделиться.
Очевидно, вы не тот экран выделили.
Но
Нет,
вы
у меня-
попробуйте столом поделиться, так обычно быстрее бывает.
Сейчас
Если
попробую
рабочим
еще раз.
столом поделиться.
Да, я вот как раз рабочий стол.
У меня вот без 15:10 зашел, поздоровался со всеми. И все было хорошо, а в 10 ровно начать не смог. Так что, потому что отключились почему-то и колонки, и микрофон. Так что всяко бывает.
Вся страна начала конференции, наверное, поэтому.
Да.
Да.
Занятия и так далее. Тренинги
Трудились.
всякие.
Перезагрузка не помогла. Сейчас с телефона сижу.
Смотрите,
проблема не с браузерной версией. Я вот тут как бы вроде как все поделил.
нужно рядом с микрофончиком есть кнопочка право поделиться, такой прямоугольничек со стрелочкой вниз. Щелкайте на эту кнопочку, появляется окошко. Откройте доступ к рабочему столу. Потом щелкайте на рабочий стол, там будет миниатюра вашего рабочего стола. И после этого станет активной кнопочка синенькая, на которой написано «Поделиться». Вот нажимаете на нее, и тогда все участники будут видеть весь ваш рабочий стол. Это самый надежный и простой способ продемонстрировать презентацию.
Евгений Васильевич, а у вас доклада нет, коллеги? Может
Нет,
быть,
если он
компьютер?
КомТех, если не получится, можно скинуть на КомТеч адрес, и я открою, тогда придется только говорить дальше.
Да скиньте сейчас, может это быстрее будет.
Так и не появилось, да? Я вот по шагам,
Нет,
которые вы сказали,
нет.
прошел, но...
Вы Евгению Васильевичу скиньте, пожалуйста.
На
Сейчас
КомТеч
разместим.
сведуру, как заявку посылали и так далее, пришлите тогда.
Да, я сейчас, наверное, попробую тогда еще поставить не браузерную версию, а сам Teams на компьютер и переподключусь. Может быть, тогда пока что кто-нибудь другой сделает доклад, а я после него.
Конечно, давайте тогда перейдем к следующему докладу. Вот, без проблем. Я тогда, извиняюсь, коллеги, перейду на английский язык, поскольку следующий докладчик у нас, он сначала представлен на русском языке, профессор Ратмаднив Дешмух, Департамент компьютерных наук и информационных технологий, Университета Маратвада, города Орангабада из Индии. Профессор Дешмух, how are you? Can you hear me? I can't hear you. Please switch on the microphone.
Yeah. Now I am audible. Hello.
Hello, dear professor. How are you?
Fine. Am I audible? Can you
Yes.
hear me?
Yes, we are here. We are hearing you.
Okay. Good morning, professor.
Good morning. You can switch on. You can switch on your presentation.
Okay. So it's my turn. Okay. So I will share my screen or this one. Okay.
Not yet. We are waiting, and we want to thank you that you are with us.
Yeah. Thank you very much.
Yes, we can see.
Okay.
Everything is good.
You can see.
Yes, everything is good.
Okay. So good morning, friends. Honorable Dias, Director Professor Boldirev Anton, my friend Professor Iftikhar Abaso, and the dignitaries on the dais present here, and all the participants and senior, that is the senior or junior, all the scientists and students and researchers. So friends, first of all, I would like to thank the organizers along with Director Professor Boldirev and my friend Professor Iftikhar to join with you and have interaction with the participants in this prestigious international conference, КомТех 2020. So friends, here I would like to share some information or details about my university. I am working in the Dr. Babasaheb Ambedkar Marathwada University, Department of Computer Science and IT, as a professor, as my university has been established since the 1958, and it is the oldest university in the state of Maharashtra, India. And more than 4.5 lakhs students are studying in the university and affiliated colleges. Along with it, I will proudly say that as India and Russia are the older friends since the before the independence of the India. So this slide is dedicated to the friendship of India and Russia. So friends, namaste from India. So in continuation that, Professor Iftikhar Abaso from the Southern Federal University, Russia, has visited my university and department under the MHRD scheme, that is GAN, for 1 week course during 16-17. He was here for 1 week. Also, I have visited this SFU campus at Taganrog as well as Rostov, and I had a meeting with Vice Rector Professor Mukhanov as well as Director and my friend Professor Bolderev, along with the Professor Iftikhar Abaso and his team at Department of Engineering and Computer Science and Computer Design. And I was also the part, or I attended ComTech 2019 during last year. Today also I supposed to be there as a part of this prestigious event, but due to this corona situation, nobody can move from anywhere or from any place to another place, and that's why this conference is being conducted, I think, on the remote base. Everybody is sitting on his place and doing the business whatever is possible. So friends, this is my today's agenda for the speech related to the research activities going on at my department and my lab. So I would like to share that my department is supported by prestigious UGC SAP program as well as DST FISH program from the Government of India. And under this DST FISH program, I have got the research project or research grant more, that is about 1 crore and 25 lakhs Indian rupees. And we have set up a very prestigious and very unique lab under this scheme, and we have procured the equipments as like this field spec 4, what you can see in the picture, which is costing near about 50 lakhs, and other resources available at the department. So friends, this equipment works on the principle of source of energy or solar radiation, which falls on the or light. This light will interact with the matters in different ways. Some light will be transmitting through some materials or while reflecting or scattering of the on the other objects. And both the material and the color, that is wavelength of the light, affects this interaction. And the study of this light phenomenon is referred as a spectroscopy. Here in this figure, you can see that the light is falling on the object, and some part of light is being reflected, some part of light is being transmitted, some part is scattered or absorbed, and this will generate a unique spectra, and that unique spectra is being captured by this unique equipment. I would like to share that this facility is available merely at the IITs in India. We are the only state university where we are having this sort of research facility and lab setup. So this ASD field spec instrument, which is procured under this program, is a full range spectroradiometer which delivers the fastest and most accurate spectral field measurements. This field spec 4 is a study of interaction in between physiochemical characteristics and spectral signatures, characteristics of the object. And the spectroradiometer have been used to detect or detection identification, verification, and quantification of various objects. So friends, these are some of the technical specifications regarding this equipment, but I will not go in the details due to time constraint. You can check this on your this one. But this equipment is having that is 3 ranges, that is VNIR, SWIR1, and SWIR2. Okay, and spectral range from 350 to 2500 nanometers. And this equipment is having a huge area of the applications. There are so many area of applications for this equipment. So this equipment can be used in mining field for various sort of application, as well as industrial mineral analysis, petroleum field, as well as resource, that is remote sensing and geological study of the various aspects. So friends, here I would like to elaborate one of the application in mining by showing this video, which will be you will get a more detailed idea about this equipment. So
at ASD, we have a tradition of expanding the limits of our technology into new application areas. We really have one mission, and that's to make it easier for our customers to use our technology in whatever area of business they happen to be in. We've been doing this for over 20 years now. We've been working in industries related to mining for most of those 20 years. ASD was founded by geologists and earth scientists focused on applying remote sensing to geology. Today, ASD customers span 70 countries across industries as diverse as remote sensing, pulp and paper, pharmaceuticals, and mining. To put it simply, we apply near-infrared technology to identify and quantify the composition of many materials, from wood pulp to the mineral content at prospective mine sites or crushed ore in production. For the past 10 years, ASD's robust, high-performance portable instruments have been used in the field by geologists conducting early mining and mineral exploration. ASD's instruments are particularly well suited for the rapid analysis necessary to make decisions during metallurgical processes. Our non-contact, non-destructive spectroscopy instruments can simultaneously measure a wide range of ore properties. For example, it can optimize heap leach operations by measuring the abundance of swelling clays, acid consumption, hardness, and total fines. Easy-to-mine deposits no longer exist. Mines want to maximize the amount of extracted metals in the least amount of time at the lowest possible cost. ASD can provide better, faster analysis of even the most complex deposits to reduce cost and increase throughput by providing better process visibility. The TerraSpec Explorer is a rugged portable spectrometer designed for mining exploration fieldwork. Applications include geologic mapping, mineral identification, and chip and core analysis. Many minerals transmit characteristic wavelength signals that the instrument can interpret as optical spectra. Using the TerraSpec Explorer, geologists can identify key alteration minerals in real time and rapidly map alteration zones associated with porphyry copper deposits. When paired with GPS readings, deposit mapping is even more efficient. The TerraSpec Examiner was designed for lab and production applications such as site mapping, block modeling, ore sorting, and mineral analysis. It leverages traditional sample analysis techniques such as X-ray diffraction, ChemScan, and wet chemical analysis to quickly analyze a much larger number of samples on site. ASD's Summit Cal Solutions team is working with mining operations to develop calibration models that leverage lab analysis to produce immediate information about ore samples. Analysis that used to take days now take minutes or less. One copper mine now measures nearly 1,000 samples a day with less than 24-hour turnaround, something never before possible. Analyzing more samples faster means better visibility into mineral processing needs, so the mine can quickly adjust its processes to increase yield and manage costs. What does the future hold for mining as spectroscopy becomes an integral part of nearly every phase of production? The next logical step is bringing the instrument to the conveyor belt to allow real-time measurement of multiple constituents simultaneously for faster, tighter process management. The QualitySpec 7000 is a stationary, high-speed NIR mineral analysis unit situated over the conveyor belt. In copper production, the quality spec 7000 is used in agglomeration to optimize acid usage and water addition, resulting in reduced acid costs and increased yield. The quality spec 7000 accurately measures non-uniform material containing minerals, clays, and physical properties. This over-the-belt analysis technique is destined to become the new quality and process control standard of the future for globally competitive mining industry. The accurate real-time information produced by near-infrared analysis and the resulting visibility, process efficiencies, and cost savings make it the ideal choice for mining applications. ASD offers spectroscopic technology, solutions expertise, and the customer service to support it all, from exploration to production.
So friends, in similar way, here this equipment are having a varied or huge areas of the applications, as it can be used in this industrial mineral analysis or remote sensing and GIS, geological ecology study applications, and petroleum area related applications, as well as it is very useful in defense and intel service, as like we can detect a disturbed surface, or we can have a near shore operations, and so many applications in the area of defense and intel, as well as we can this can be used in so many environmental applications, as like a climate effect analysis or landscape ecology and ecology research, characteristics research of the ice or snow research, atmospheric remote sensing research. So also this is most useful in the material analysis, so as we can identify the content, that is contents of food, and we can check the quality or the quality of the food or the contents of the food as per the standards, as well as we can detect the ingredients of the pharmaceuticals and dairy supplements. Also there are so many much more applications in agriculture. Also we can make a soil analysis, as well as grain and seed analysis, biomass analysis, or we can study the plant physiology, or there are so many commercial agriculture applications also. And as India is a agriculture oriented country, that is more than 60% of the population is dependent on the agriculture, we are more focusing on the agriculture sort of or type of application on the soil or plant analysis and related applications in our lab. So this is the example of the spectra or spectral signatures taken out of the that green line can show the vegetation signature, that brown line can show the dry grass signature, and this blue line shows the soil spectra or soil spectrum of the sample. So here this is again a typical example or spectra of the vegetation, where we can see the chlorophyll absorption area as well as water absorption area, along with reflectance due to the sponginess of the leaf. And these are the base. At base you can see at wavelength it is a visible near infrared and shortwave infrared sort of wavelengths are available, and they starts from 300 to 2500. This is the biggest range of the micro, that is of this equipment, and this equipment is being procured from the USA, as it is not available in India also. So these are the some of the absorption features of the vegetations, out of which at the particular wavelength band we can find out the particular chemical as like chlorophyll, protein, nitrogen or water content or cellulose and so on at respected bands. So friends, what we can do or predict from the vegetation reflectance, so we can predict the grain yield of the plant, or we can observe the plant growth and stress of the plant, water stress of the plant, as well as we can find out the chemical contents as like nitrogen, phosphorus and potassium. We can study the plant health, as well as we can detect the sort of diseases and its effects on the plant, or we can discriminate, make a discrimination between different species, or we can identify the vegetation species in different ways. Okay. So these are the some of the vegetation indices by using which we can make an analysis of vegetation or plant in many different ways. So this is the sample spectral signature of a soil, which is showing that is lower organic matter as well as higher level of organic matter within the soil at the different bands or bandwidths. Okay. So again, what we can predict from the soil refractance, we can estimate a water content or moisture content of the soil, as well as we can estimate the content of soils as like copper content, nitrogen, carbon, calcium, potassium, magnesium, sodium, phosphorus and zinc, and so many. So these are the some of the vegetation indices for finding out the different ingredients of the soil and make an analysis of soil, and on the basis of which we can generate a Kisan card or farmer's card. On the basis of contents of the soil, we can identify the type of soil and which crop will be suitable for a particular soil. We can recommend the soil, that is a type of crop, to the farmers on the basis of this analysis. So as for this that is correct or proper analysis or getting proper, accurate or appropriate results, what is needed, there is a need of proper data collection for identification of the material or quantification of the material or quality analysis of any object, or acquisition of correct spectral signature is an essential part, as well as proper measurement must be taken while collecting a spectral data because of many factors affected which affect the spectral signature. Friends, so these are the some of the standard measurement steps while going for the data collection, while that is starting for the data collection. That is, first we have to warm up the equipment for 15 to 20 minutes. Then we have to decide the field of view. After that, we have to optimize the equipment with dark current and white reference. And then we have to start for capturing the signature of the material. So again, here I would like to mention, we can take a signature of solid material, liquid material, or any sort of material for the analysis and study. So this overall setup of the library equipment, that is this equipment setup available at the library. And beside this setup, we are also having other facilities, that is related facilities for the study of GIS and remote sensing. Along with this equipment, we are having a license copy of 10+ license of this ArcGIS, NV, and ERDAS imaging softwares. Sorry, one moment. So ERDAS and high resolution printer, along with the facility of purchasing or procuring a satellite data from the NRSC Hyderabad, which is a nodal agency of the India at the national level. Okay, sorry. So after this, that here is a details about the some work which is going on at our department or lab. That is, at our lab, the PhD research scholars are working, as well as MPhil students and MTech students are working on different aspects of the agriculture plants as well as soil, as like a winter crop discrimination using field hyperspectral remote sensing, or classification of crop types, or design and development of spectral signature of crop, or analysis of air pollution on chlorophyll, water and carotenoid on the plant, along with so many related topics. Then for soil, the spatial and spectral feature extraction of the soil, or creation of a soil spectral library, or identification of arsenic content in soil using spectral signature, monitoring of hydrocarbon contamination of agriculture soil, and so many. Along with, we can work, or we can study, or we can make an analysis on the basis of biometric objects also, as well as fruits, or we can study or make an analysis on the medicinal plants also by making spectral signatures, or by using the spectral signatures of this equipment, which is having a varied applications. So so many students, research students from my department are working on various crops, fruits, soil, medicine plants, vegetable plants, and pulpinate recognition plant, as well as we are creating a library for vegetation, soil, and different aspects. Whatever work is being done at the department. So here are some Android applications being developed by the students in subsequent part, or at last finishing their work for. That is, for example, app is developed for spectral estimation of soil moisture using ISER model, or another we can say hyperspectral analysis of soil total nitrogen using PLSR method, or estimation of soil organic carbon contents using different reflectances, that is indices, or spectroscopic determination of above ground, that is above ground biomass in the grass, or estimating copper content in the agriculture soil by reflecting spectroscopy, or prediction of phosphorus content in the different plants and comparison of that, as well as so many. So there is no limit where we can use this equipment in varied ways. So in conclusion, I would like to say that this hyperspectral remote sensing of application includes geology and mining, defense, environment, agriculture, and material quality assessments, as well as we have seen that the selection of optimum waveband to study different applications is a very important or consensus view based on the broad range of the literature reported, and acquisition and understanding of the basic spectral signatures is a very essential in every application domain. So friends, at last I would like to make an appeal to all the researchers and faculties of Southern Federal University that anybody can come forward to take advantage of these facilities remotely, or by actually you can come to this campus, as my university and Southern Federal University has already signed MOU to work on the basis of the research and different activities. I would like to welcome any researchers or faculty from the SFU campus, that is Rostov campus or Taganrog campus, and also you can have an opportunity to worldwide heritage sites like Ajanta and Ellora, which are located nearby Aurangabad, which are world famous Buddhist caves, along with the Bibi Ka Maqbara, which is the replica of Taj Mahal, and many more sites which are historical sites and very interesting sites. to visit along with your research or regular work. So friends, with these words, I would like to again thank Director Professor Boldirep Anton as well as Professor Iftikhar Abaso to have a part of this prestigious event or a conference and calling me for the having interaction with the participants. So thank you, thank a lot. So over to you, Professor.
Thank you, Professor Deshmukh.
Yeah, thank you.
It was very interesting presentation. Thank you very much.
Thank you. Yeah.
I will speak Russian for my colleagues.
Yeah, sure.
Уважаемые коллеги, если есть вопросы, прошу задавать. Можете задавать на русском, я переведу. Пожалуйста.
Ну, у меня вопрос
Угу.
такого плана. Можно ли создать дешевый и простой прибор для вот персонального использования на этом принципе? Ну, скажем, для экологии, анализа там еды, ну и так далее. Вот как сейчас делают, в общем-то говоря, приборы.
Dear Professor, we have a question to you.
Yeah.
Is it possible to design such a device, cheap and reliable, on this principle work for ecology, for food?
Yeah, because this is a very costly equipment, and designing this equipment will require much more knowledge of physics also and electronics branch also. So this basically the equipment is working on the principle of microwave radiation. So designing this equipment is another part, and doing research by taking advantage of this spectral signatures or outcome of this equipment is possible. So we can study various ecological analysis, or we can do various ecological studies with the help of this equipment. I would like to share that this equipment is a portable equipment, and this can be used in the control situation in lab, as well as you can take it on the field. You can take a reading or take a spectral signatures, and you can work or make analysis of